Record.
Yeah.
Oh, yeah, I see what you did there.
Yeah. That's
So we spent a little bit of time just with the basics of evaluating a function. Today, we're going to look at how to compose two functions with each other. This will be a several day endeavor. This is not a quick one and done kind of thing. So there's another way to do this, a visual way. And I thought, yeah, I kind of had a mental coin to flip. Do we want to do the graphy visual way first or the algebra way first? And the coin toss came out on let's do the algebra first. At some point, you'll see this holistically for what it is. But today, it's just going to feel like a bunch of kind of grindy grunt work. So I have four examples for you, technically eight, but there's four main ideas. So let's get to it. So here's what it's going to look like. You're going to have a function. I think in every problem you'll see today, you'll have one function whose name is f of x. Thank you, Sutter. And then you'll have another function whose name is g of x. I have made the choice, this was not a coin toss, to teach this lesson in the order of more difficult problems before simpler problems.
so you could
So our first couple of examples, we're going to be without inputs. Like the second half, I'll be asking you questions that involve like math, where you can like put five in place of all the X's and, grind it out. Um, at the beginning of this, we're going to be doing just purely algebraic composition. So here comes the notation and what I want you to get used to seeing. I'm going to write this down and you can try to read it to me out loud. We're going to do this. Anyone want to try to read that out loud?
f of g of x.
Perfect. F of g of x is how we say that. And so this is what a composition looks like. And out of respect for you and the fact that you'll see things differently in different books, or maybe like in your online college classes, another notation that people sometimes use for function composition is a little circle that's raised up. Almost looks like the word fog. So I'm not going to use it after this moment in time. I'm just going to show it to you once so that when you see it, you'll know what they mean, what the meaning of it is. You could see f of g of x written like this: f of g of x. I elect not to use that notation. I find it to be distracting. I find myself constantly thinking of like the John Carpenter movie from the 80s called The Fog. And so for me, it's a distraction. I don't like it. I don't like fog and Goff and stuff like that. So that's why I elect to use the top notation. All right. And when you're writing it down, try to be cognizant of the fact that you want parentheses to not be the same height. So I go out of my way to make the embedded function have a little bit of a smaller thing so that you can kind of see how they stand out. All right, let's get to what this looks like. So to do f of g of x is quite literally a matter of putting g into f. It's the same. Listen, if I said, let's do f of 5, I wouldn't write this down if I were you, but if I said, let's find f of 5, what would you do? You'd plug 5 into which function?
The g of x.
F. I mean, it literally right here says find f of 5. So I would go, okay, I'll go to the function named f. It's this one, and I'll change all of his x's into 5s, and the answer is negative 29, like bore me. So we're going to employ the same thinking in your practice with this because you've already kind of worked through this in an assignment, just different notation. If I say find f of g of x, I'm asking you to do negative 3 times blank minus 14. Notice though, I've left an obnoxiously long blank because what's going into where the x used to be?
The
The g of x is, right? So g of x is effectively substituting himself in to the f function. And so it's negative 3 uh, times x, but x is now negative x squared minus 4x plus 9. So can you see that the entire g function got just dropped in? And now it's just simple algebra like this. What you're going to find with compositions is one direction is generally easier than the other. So I thought I'd start us out with the simple one that just involves a little bit of like eighth grade distribution. So when we distribute the negative 3 through, we get 3x squared. We, of course, get plus 12x, and then we're going to get minus 41. And that, I figured at this level of math, I could probably skip some steps. So that's what f of g of x looks like. That's it in its simplified form. Now, what you're going to find is when we go the other direction, it's not going to be quite as pleasant of a process. So when we compose in the opposite direction, when we do g of f of x, this is going to be more laborious. And it's not unique to the situation. Like I said, generally one direction is going to be more pleasant than the other. So the problem this time is that we're putting into a quadratic. And so, yeah, it kind of sucks. So here's what it's going to look like in its sort of raw form. It's going to be negative blank squared minus 4 blank plus 9. And you got to kind of buckle in for this because it is like significantly more algebraically taxing than the first one. What are we going to put into those blanks?
The negative.
The f function. So we're going to change this one into negative 3x minus 14, and we're going to change this one into negative 3x minus 14. And that's some doing. Thank goodness we have nice little tricks like square, square, multiply, double that will save us a little bit of time. So I'm going to scroll the screen up now so I have lots of room, and here we go. First things first, this negative that I'm circling in green has got to be put on the back burner, right? He has to wait his turn. Our focus is what's underlined in yellow. And if we do the square, square, multiply, double trick on that, anyone want to give it a shot?
9x squared
Perfect.
plus 6x. No. Maybe
What if I said to you it was plus 84x? Would you think I was crazy? So remember, the idea when we do square, square, multiply, double is this. I'm going to color code this for you. You see Mr. Purple? And you see Mr. White? Multiply them together. What's negative 3 times negative 14?
well, 84.
It's 42. And remember that you have to double whatever you get because there'll be 2 iterations of that throughout the course. And so if you get 42 and you double it, you get 84. And then at the back, I apologize. I hadn't really worked through this problem, but we're all tough. At the back, you have to do 14 squared, which is 196. Now, what I'm going to do is I'm going to take that negative sign and I'm going to bring it down. And we'll get down to that in a second. So again, the square, square, multiply, double can be a big time saver. If it's uncomfortable for you, eventually you'll learn it because you want to, because you'll get really sick of writing it all out the long way. You'll learn it out of just necessity, I guess. The second half of this is we have to take this negative 4 on the right-hand side and distribute it through. What do we get?
12x and 56.
Plus 12x plus 56. Yep. And I don't know that there's really any benefit to combining the 56 and the 9, because eventually you're going to have another number that's going to come kick in the mix too. So whatever. The negative distribution, I'm going to go ahead and tackle now. So that's just going to change all the parenthesis guys to their opposite. So we're going to have negative 9 of those, minus 84 of those, minus 196, and then we'll just copy down the rest. It would be good for like an Algebra 1 student to sit through this lesson just so that they can see, if you're going to take more math classes, the importance of just having good fundamental skills, right? Negatives and all that stuff. So we're going to write our answer in standard form. So the x squared term should always go first. So we're going to say that for our final answer, that g of f of x is equal to negative 9x squared. How many x's are we going to have? Nice, negative or minus 72 x's. And then the constants can be probably calculatorville, I'm thinking. Negative 196 plus 56 is negative 140, right? And then if you add another 9, I believe that's negative 131. So I think we're looking at minus 131. I'm asking you just out of respect for your time, would you like another example like that, or would you like me to skip ahead to the sort of second half and show you where also we're going? Would you like to just jump? Do you understand that process, right? To do f of g, you feed g into f. And to do g of f, you feed f into g. And that will really be assuming your algebra skills are up to snuff, then your main hurdle will be, what do I put into what? But you can always remember it as the one that's inside will go inside. Maybe that's a stupid thing to say, but like, because it's inside, it will go into the other function, right? You'll figure it out. All right, so I'll skip a little bit, and if you want another example, I will keep this one in reserve, but I'm going to reholster that one and jump ahead to the second part. And you'll like this a lot better because it's like a trillion times less annoying. So here's our next example. We have a function named f, and he is 3x squared minus x and plus 6. And then we have another function named g, and he is negative 2x minus 1. I'm trying to be consistent with what the assignment's going to look like for you. By the way, we are going to be working in Delta Math. It's our first time this year, so we'll have to get the class all set up and everything. But in Delta, what I noticed from clicking through all the problems is that it seems like every time it gives you one quadratic and one linear. So I'm trying to stay true to that with these problems. So you're going to know, I hope pretty quickly why these problems are infinitely more enjoyable. And here it goes. So my problem is not going to be, I don't want you to find f of g of x. I want you to find f of g of negative 2. And you'll appreciate when we get to what we're doing maybe tomorrow, and you see this from a graphical perspective, you'll understand intimately like how slick this is. You're using one function's output as the input of another.
Mm-hmm.
And in those last examples, it kind of sucked because we didn't know what the output was. The output was like nonsense, algebra, x squared plus 5x. But check me if I'm wrong. I believe, aren't we all capable of figuring out what g of negative 2 equals?
Yeah.
Shouldn't take long at all, should it? It simply means to go to the function named g, and wherever he has an input, wherever that red arrow is pointing, just stick in a negative 2. Do it in your head. What's negative 2 times negative 2? Positive 4 minus 1 is 3. So what this problem is really asking you to do is quite simply find f of 3. The output of one becomes the input of another. That's the essence of a composition. To find f of 3, I'm going to recolor code this for you now. We're going to take the number 3 and we're going to put it where the purple arrows are. Good? So we're going to do the purple jelly bean first. What is 3 squared?
9.
9. What's 3 times 9? 27 minus, and then this one, I don't need to do any math. It's just literally 27 minus 3. And what's 27 minus 3?
24.
24 plus 6.
30.
So we say that f of g of negative 2 is equal to 30. A lot easier, these ones, because again, we can avoid all the unknown. When you're toting unknown things around in math, math is always harder because you're always toting around x's and exponents and things that you can't commit to. But when you can commit to like numbers, boy, math is a lot easier. All right, let's do the same problem, but let's go in the opposite direction. So this time we're going to compute g of f of 3. So what's our first task?
Go to F and plug 3 in.
Absolutely. Go to the function named f and plug in some 3s.
Well, yeah, that'd just be 30.
We already know what this one is, right? And so to save ourselves some time, how convenient, we can say that f of 3 is equal to 30, correct?
Mm-hmm.
So this problem is actually just asking us to find g of 30. Nice little time saver there. And now I'm just going to turn around and feed that output in as my new input, right? And where's 30 going to go? Where the red arrow is this time, because G is my new machine and his input is the 30. If you put a 30 where the red arrow is, what's negative 2 times 30?
Negative 60.
And what's negative 60 minus 1? So we can say that G of f of 3 is negative 61. So you see that this is the tale of two types of problems. One is annoying and difficult where you have to do everything in terms of X and there's all sorts of basic skills. And then one of them is really pleasant and just like a smooth walk through the park. Is that enough examples? Okay, so that's what you're going to be doing today. So I'll pause this. Well, maybe I won't. No, I will for a minute. We have to get our Chromebooks out and go and get our Delta Math class all set up since it's our first time. Yeah, so when you get to that place and you click add new class, my class code for your 8th hour class is S7VY-7M2A. And that should get you into the class. Should say eighth period advanced or I don't know, AMT. Yeah, okay. So I'm going to repause this so I can start jumping around here.